Hello, this is Amy Brown, Director of Events and Education for Trade Press Media Group. Thanks for joining us for today's webcast, Power System Performance, Digitalization and Actionable Insights. Our presenter today is Drew Latimer. Drew is an offer manager at Schneider Electric's U.S. Digital Power Division, responsible for the productive relay product portfolio. He has been with Schneider Electric for 13 years, having held roles in strategic marketing, product management, engineering for metering and low voltage equipment product lines. He has an MBA from Middle Tennessee State University and a BS in mechanical engineering from the University of Kentucky. Today's webcast learning objectives include understanding power management trends, systems, and benefits for facilities. Learn about electrical distribution system components, capacity management, and data points, and discover how product system performance data can be collected and used to improve efficiency and operations. Before we get started with today's webcast, I'd like to just cover a few details with you about the event. A live question and answer session will follow today's presentation. To submit your questions, please navigate to the bottom of your screen and check the Q&A button to type in your questions. Our presenter will answer as many questions as time permits. Today's event also includes an interactive multi-choice polling question. Your input is very much appreciated, so we ask you participate in this poll. At the conclusion of today's webcast, you'll receive a PDF copy of today's presentation slides. You'll also receive a link to a brief online assessment, and upon completion of that assessment, you'll receive your CEU certification. Today's webcast will also be archived at facilitiesnet.com/webcast. And with that, I'll turn it over to you, Drew.
Good afternoon. I appreciate you attending the presentation today on power system performance. I wanted to start off with, just a couple of the things to start thinking about. Did you know that today there are 10 times more connected devices in the world than there are connected people? Over the next 20 years, we're going to see the demand for electricity grow twice as fast as the demand for any other energy source out there. And in that same 20-year period, about 70% of all new electrical capacity will be in the form of renewables. Electrical distribution systems are becoming much more complex with more sensors, more metering points. And because of that, businesses need to have better tools for handling the sheer volume of data that's being collected. Even today, it's a true problem for many facilities and businesses, the overwhelming amount of data that power performance systems are collecting and analyzing. In terms of electrical monitoring, there's often too much data coming in, and in that case, operators simply are not able to keep up. In the end, we see that too much data is not useful if it can't be quickly interpreted and acted upon. So the good news for us is that there are these things called energy and power management systems that are rapidly evolving to address this data issue. And it all comes down to how the data gets processed, how it gets analyzed, so that that information can be turned into simple, actionable insights. All right, so what we're going to be covering today, three main areas of focus. I'll start with just a high-level description of what power management systems are and how they help people and businesses. After that, we'll take a look at some of the major future trends in the market and how those trends will impact power management. And finally, we'll take a look at some of the most valuable attributes of power management systems so that you will be able to know what to look for when investing in your system going forward. And as Amy mentioned earlier, we'll have some time at the end of the presentation for Q&A. All right, so let's start by looking at what a power management system is and how it helps people. Let's look at what kinds of businesses and customers use power management systems, what a power management system looks like, and looking at some common power management applications. So power management is really I guess a specialized discipline. It's focused on the operation and the maintenance of electrical distribution infrastructure of all kinds of different facilities. Uh, in a nutshell, it helps ensure the safe, reliable, and efficient delivery of power throughout those facilities. And it involves intelligent metering devices that are connected upstream to different kinds of software packages for things like data collection, visualization, analysis, and a variety of different reporting means. Just like any other critical process in your facility, your electrical distribution infrastructure is an operational asset. Like the other assets, it needs to be monitored, it needs to be managed, and it needs to be maintained in order to keep your business running. So as I previously mentioned, power management systems are designed to ensure the safe, reliable, efficient, and compliant operation of your electrical distribution system, as well as the assets that are connected to it. These power management systems can help avoid electrical fires, prevent shock, as well as to recover from outages and get the power back up and running quickly and in a safe manner. They're used to avoid unplanned outages, as well as increase electrical asset and system performance and reliability. They're important for reducing energy costs as well as optimizing maintenance. And they really help simplify the process of acquiring and maintaining compliance to industry standards and regulations for things like energy management, carbon emissions, and even power quality compliance. So what kind of businesses use power management systems? Any business that operates large and critical facilities, so anything from hospitals to data centers, to different infrastructure facility, airports, rail systems, all the way to manufacturing facilities, from oil and gas to automotive plants, to water and wastewater treatment plants, as well as commercial buildings. All of these different types of facilities, both critical and non-critical buildings, use power management systems. So some of the buildings, commercial buildings like hotels, malls, educational campuses, facilities like that. They all rely on their electrical infrastructure to deliver high quality power to keep their businesses running. So as we take a look into the future, we're going to see more and more businesses that need these power management systems to remain competitive and continue to operate as efficiently as possible. So where does it all begin? Power management it's all based on having real-time system-level visibility of electrical parameters throughout your facility. So not only the very basic things, measurements such as voltage, current, frequency, but also looking at attributes that give users information and insights into the quality of the power being delivered. So we can see things like power factor, harmonic distortions, more advanced electrical parameters as well. It's also important for detecting things like current leakage, ground current loops, excessive harmonics, especially large and critical facilities. They use power meters to monitor all of these parameters in real time in order to operate and maintain that safe, reliable system that's paramount. So sticking with power monitoring basics, you'll see a very basic one line here of facility, all kinds of different loads with meters monitoring those different loads, both monitoring the supply power coming from the utility as well as the load power that those loads are drawing down further into the electrical hierarchy. These meters are specialized measurement devices that provide the real-time data and power quality diagnostic information that facility management people need to operate and maintain their systems 24 hours a day, 7 days a week. These meters are installed in key locations throughout the electrical distribution system. Probably the most important location to monitor is at the main incoming breaker for monitoring the quality of power supplied to the facility from the utility, as well as measuring the total amount of energy that the facility is using. We'll also see meters installed in downstream switchgear and distribution panels monitoring power that's delivered to all of the different equipment and loads in the facility. In this very basic example, the meters are monitoring loads from HVAC equipment to compressors and other different manufacturing equipment. So data from all these metering points is used for monitoring the health and efficiency of the system, for capacity management, for monitoring of the equipment, and power event analysis. So the system architecture of a power management system is centralized, and it's relatively simple compared to other systems. If you think of a SCADA system, which may have more of a distributed architecture that has several software components, I/O, communication, alarm, and reporting servers. So most power management systems can do all their data acquisition, the storage, analysis, and the reporting on a single power management server without the need for installing multiple components on separate computers. So for us, this keeps things simple and cost effective. The systems are designed to acquire data, to process that data, analyze the data, and serve up information from a wide variety of smart devices. So if you can see the slide here, we're talking about smart devices that range from everything between protective relays to power factor correction equipment, power meters, intelligent circuit breakers with integrated metering and communications, as well as variable speed drives. A good power management system is able to share their data with other systems using different interoperability standards so that information can be easily used by other systems, whether it be a SCADA system or a building management system or enterprise energy management system. Whatever it may be, that interoperability is crucial to a good power management system. Other clients can use access points over the network or even from home outside the network using VPN. But despite the simple architecture, power management systems provide a ton of valuable information. And we'll take a look at how these systems actually are able to do that. When we look at the system health and efficiency of your electrical distribution system, we're looking at the quality of power that is fed into the system. So, different types of equipment in a facility draw power in different ways, and those different ways can have an impact on the performance of your system. So things like voltage and current imbalance, those are useful for detecting things like single faults throughout the system, or problems within a piece of equipment that's no longer drawing three-phase power evenly. Things to look for, like higher than normal neutral current levels, which can identify grounding problems in the system or inside equipment. Can look at total harmonic distortion. Harmonics are caused by nonlinear loads, things like computers, PLCs, variable speed drives. Really any equipment with switch mode power supplies create current harmonics that contribute to voltage distortion. Another important measurement is power factor. Many people are very familiar with power factor, but for those that aren't, it's really a fundamental indicator of power efficiency. It's a measure of the flow of current relative to the voltage, as you can see here in the illustration on the slide. When the voltage and current are perfectly aligned, the power factor is at 100% or 1, which is also called unity. During unity, all the available power is active power and there's no reactive power. But when you have loads that are inductive, things like heaters or furnaces or motors, these cause the current flow to lag behind the voltage. In a healthy power distribution system, the voltage and current will be pretty well aligned, and reactive power will be low. So kind of as a general rule, power factor reading of 0.9 is considered good, but once you get down below 0.8, you're looking at what's considered to be a poor power factor. So the next thing that we'll talk about is capacity management. So this is talking about the monitoring of different power levels or current draw levels over time for users to get visibility to where their capacity is, where circuits may be being close to overloaded. Conversely, where circuits may have a ton of capacity for facilities to be able to go in and add new circuits without the need to invest in additional distribution equipment. You know, with capacity management, you can better understand how equipment and operations affect the current levels flowing through the system. Capacity management is a vital application when you're looking at, again, critical power facilities, things like hospitals or data centers. It's also very important in manufacturing environments where different equipment and production lines are moved, expanded, reconfigured pretty frequently. Managing capacity helps maintain a balanced system, so it avoids circuit breaker overload trips. But in addition to that, it can help reduce the cost and the risk associated with some of those expansion projects or reconfiguration projects within a facility. So a couple examples coming from real customers. There's Smith & Nephew on the first one. This was a case where no power management system was in place. So you can see that this customer said, you know, they were almost positive that they could go and add additional loads to the existing power distribution system that was in place today. But based on the nameplate ratings on the equipment and having no power management system in place to confirm the actual capacity that was being used, they had no choice but to go and add additional distribution equipment at additional cost to be conservative enough to know that they could add those additional circuits. So with the power management system and the capacity management that goes along with that, this customer would have been able to see exactly where they had the ability to add the circuits without necessarily making an additional investment in more equipment to handle the load. In the second example, this customer did have a power management system in place. So this was a large facility at the University of Maryland. With the power management system and with the visibility of the loading and the capacity, this was an instance where the original design, the size of the transformers, the size of the switchgear, was able to actually be reduced significantly with that visibility that they had in the system. This particular case was able to save this customer over $1 million in electrical distribution costs. So it's not just about tracking the current levels to avoid overloading and tripping a breaker. But in this case, you can see that there can be huge financial benefits when you use it for this kind of planning an expansion project. All right, so kind of turning back to the topic of power quality. Poor power quality coming into your facility, it can damage your equipment, it can damage your assets, it can cause malfunction or failure of all kinds of different equipment. So when we're talking about power quality, we're talking about monitoring things like phase unbalance, inrush current, fluctuations in frequency coming from the utility, sudden changes in voltage, and things like high harmonic distortion. So some of these power quality disturbances come into your facilities from the utility. But what some people don't think about as much is that many electrical problems are actually caused within your electrical distribution system. So on the right, you can see at least 5 of the, I'll call them culprits, 5 types of equipment that generate harmonics coming from within your system. So I mentioned earlier, anything with a switch mode power supply, lighting ballasts, variable speed drives, UPSs, and anything with a magnetic core introduces these harmonics into your system. So these are things to watch out for because high levels of harmonics not only reduce the overall power efficiency of your system, but they have many other negative impacts on a wide variety of equipment as well. So power event analysis. I'll say electricity has lots of unique attributes, and it can be very complex to describe and qualify. There's lots of specialized measurements coming from these specialized devices, pieces of equipment that are required to interpret what's actually going on at any given point within the system. Only a purpose-built power management software platform can make use of this specialized electrical information coming from the meters and other devices. When you think about more generic SCADA system, building management systems, and other manufacturing operations software platforms, they don't have built-in visualization tools that are specifically designed for these types of power event analyses. The analysis is really a key step in sequence of events reconstruction and recording. It helps determine the root cause of problems so that they can be resolved quickly and prevented from occurring again in the future. All right, so we'll take a pause here and I will hand it over to Amy for a polling question.
Great, thank you, Drew. It is indeed time for our polling question, so please direct your attention to the polling panel that'll pop up momentarily here. We have just one question today. Are you interested in implementing a power management system in your facility? Yes and no. Again, please take a moment to select your answer. We very much appreciate you participating in this panel. Just a reminder, we'll be closing the poll momentarily, so please make sure that you submit your answer. Thank you very much for participating in today's polling question. Drew, I'll turn it back over to you for the second half or for the remainder of your presentation.
All right, thank you. Kind of shifting gears, at this point I'd like to talk about some of the trends that we're seeing in the market and especially how they impact power management. So as we look into the future, there are a few trends that will definitely impact electrical distribution and drive the need for better power management and power management systems. So the first thing that we see is as the world is becoming more and more digital, there is a much more growing demand for an expectation to have 100% uptime, so we can all remain connected and operational. Not only in our businesses, the expectation, especially over the last few months, is really to have 100% uptime in your personal lives as well. So that expectation and trend is going to absolutely continue. Secondly, when we think about how we design power management systems and use those systems in the future, we have to think about what the workforce is going to look like. In the next 5 years, 3/4 of the workforce in the US is going to be the digital generation. So the expectation is going to be with that, there's going to be more sensors, more meters throughout the electrical distribution system, huge amounts of data being collected and needing to be processed, turned into simple, actionable information. If it's going to meet the expectations of this workforce and provide value to this workforce. The other mega trend that will have an impact on power management is decentralized energy production. So as I mentioned, about 70% of the new energy capacity over the next 20 years will be from renewable sources led by solar. And that's really to meet the growing demands for energy and power reliability. When you think about new technology, think about what's going to transpire in the next 10 to 20 years. Things like different emerging technologies like virtual reality, machine learning, prescriptive analytics, artificial intelligence, pervasive sensors collecting all kinds of data at all different areas of the electrical distribution system. So think about over the next 2 decades how different the way of interacting with your electrical infrastructure will be. We're going to get to a point where facility managers or end users will be able to take action without ever having to step foot in the electrical room. So with that workforce shift to the digital generation in the next 5 years, you can imagine that the corporate boardroom meetings might look something like this. Everybody's going to be digital. Everybody's going to be mobile. Everybody is going to trust and leverage that technology to the max. Digital collaboration will be unprecedented, and this will have to be reflected in the technologies that we manufacture and produce for power management. Another thing that's very clear is cybersecurity will influence everything we do, even much more than it already does today. We've all heard of cyber attacks being on the rise, targeting industrial automation and control systems. These data breaches can severely affect a company's reputation and can have long-lasting financial impacts. So point here is when you're choosing what devices, software, and services to use in your facility, cybersecurity is an absolute must as far as a key consideration goes. Also in the future, we're going to see much more sophisticated and highly efficient distribution systems compared to today, with more energy production being decentralized and more industrial sites and building campuses managing their own microgrids. Some sites are actually going to employ and are employing energy storage technologies and use their distributed energy sources to really maximize their own power reliability. The systems are going to be built for superior power quality performance. Things like harmonic filtration from a power quality standpoint, voltage regulation, power factor correction being built right into the design more and more. Electrical equipment's going to be smarter. The equipment's going to have more sensors for advanced operations as they send their data to the power management system for facility personnel to use from anywhere they wish. And with that ever-growing sophistication of electrical distribution systems comes an overwhelming amount of data. In the next 2 decades, I'm going to say all facilities are smart and everything is connected. As we look forward into the future, we're going to see power management systems that are going to be connected to more smart devices and intelligent equipment. And because of that, they're going to be collecting significantly more data than they do even today. So how are we going to cope with all of this data and additional complexity? Some facility personnel are telling us that they're already overwhelmed with too much data today. So the answer in how we're going to cope is really going to come down to the way that devices and software process data and turn that data into actionable information and intelligently share these insights back to the people who care and who can take action. In the last section of the presentation, I'll cover some of the key features of power management systems and talk about why these things are some of the most important considerations that you may want to take. These are things that you'll need to look for to maximize your power performance and prioritize your power management system investments in the future, taking into consideration some of the market trends that we just talked about. So when it comes to investing in power management systems, some high-level attributes to consider are the supported system architectures scalable? Can you start small and expand over time? Is the system adaptable enough to allow you to collect data from any type of device you wish, then process that data and present the information however you'd like? Is the software easy to use so you can get the information you need quickly without having to be an expertly trained super user? Does the system come with interoperability tools to share data and web application content with other systems? Does the system allow users to access information easily from a variety of different environments? Is the software web-based and browser agnostic? Is the software designed to have its power management web applications hosted inside other web environments? Can you access information from mobile devices? Are the system components designed to be cyber secure? Do they comply with cybersecurity standards? Do they support data encryption and secure communications? And finally, you should always think about the level of service and support that's available to help ensure that you're successful using the system throughout its life cycle. So now we'll talk about some important features that make these power management systems unique and highly valuable. The first thing that makes a power management system different from other systems is the specialized nature of the electrical and power quality data that they provide. On the slide here, you'll see things like power quality meters. These specialized devices have time-stamped power event data, so they're time-synced throughout the entire system. They have onboard data logging and data processing. They provide high-speed sub-cycle alarms, so these devices are capable of sampling at the thousands of samples per cycle level. Power disturbance information and waveform captures, so visibility to things like voltage sags and swells, harmonics, and having the ability to pinpoint when and where an event occurs in the system. Similarly, but not as complex typically, are intelligent circuit breakers. Again, these devices have timestamp trip event data. They give visibility to the breaker settings themselves. Also, in some of the higher end intelligent circuit breakers, there's the capability for waveform capture as well. The breakers are able to capture diagnostic information for each event that they see. Another thing to consider that's often overlooked is the built-in data model for power and energy. So what this is, it's really a predefined data model that have measurement names tied to the attribute. So what this does is it enables consistent mapping of the data names and parameters across different devices, across different models of metering devices. So the software in the power management systems knows exactly how to handle that specific data regardless of the device that it's coming from. So they have to know, these systems have to know how to handle specialized measurements like the ones you see here. All these specialized measurements have to be recognized and handled properly by the software in order for the software to provide the value from the standpoint of data visualization, analysis, and reporting. Power management software comes with pre-engineered built-in data models for electrical measurements. The data model defines standard measurement names and attributes for all kinds of different measurements. So having a data model designed specifically for electrical power and energy measurement is essential to ensure everything's correctly mapped to standard measurement names regardless of where they're coming from. It's the power data model that tells the software how to roll up standardized measurements for visualization and reporting. And one of the biggest benefits of a built-in power and energy data model are project deployment efficiency, as well as general data consistency and accuracy. So thinking about the more generic SCADA systems, the building management systems, and so forth, those software platforms don't have the pre-engineered data models built into them. So in these cases, as you can imagine, the specialized electrical measurements of interest have to be defined manually. So it goes without saying that anything like this done manually is going to be very time consuming, prone to human error. So what ends up happening is software system integrator, for example, usually only maps the most basic electrical measurements into the software versus having the full suite that the built-in data model of a true power management system provides. So point here being, if you have invested or are planning to invest in power meters and smart breakers, you need to use a power management software platform that's specifically designed for the purpose. So I mentioned the visualization from the software package for electrical information. So once you have the electrical power and energy data mapped and defined in the software with that built-in data model, the next steps to turn that data into useful information that you can actually go and use. So to do this, the software platform has to have electrical domain logic and specialized visualization tool designed for electrical system monitoring and power quality analysis. Power management software platforms provide visualization that you can see here in the slide. Things like waveform analysis tools, phasor diagrams, harmonic histograms, and ITIC curves. You look at the lower left-hand picture, you'll see blue and red dots overlaid on a curve with upper and lower limits. This is an industry standard known as the ITIC curve. It's designed to show the frequency and severity of voltage disturbances so you can quickly and easily see how many power quality events have occurred, as well as which ones may have had damaging effects on specific equipment. So remember, generic SCADA, building management software packages, they don't provide these kinds of visualization or analysis tools. Kind of staying on the topic of software visualization, 20 years ago, collecting data from the devices over a communication network and serving those values up on a computer screen, it was considered pretty high tech. As times have changed, smart devices and smart equipment are providing so much data now that, as we've said, it can be extremely overwhelming. We've seen studies that show when too much data is presented to operate, they'll overlook a lot of it, or in some cases get to the point of ignoring it altogether. So when too much raw data is presented, it can be a bad thing. What you want, what customers want, are insights and decision support. So they can quickly and easily understand what's happening in the system and what actions need to be taken. So with that, power management software platforms come equipped out of the box with a comprehensive set of built-in reports that are specifically designed for all kinds of different power and energy management applications. As an example, there are standard reports that will describe your facility's power quality situation relative to recognized industry standards. There are reports on energy management tools, things like energy cost allocation, energy modeling, and forecasting, among many others. But depending on what your goals are, what your application is, these built-in reports are extremely valuable to cut to the chase and give you visibility to what you're most interested in. So I mentioned interoperability and accessibility earlier as being a key consideration to selecting a power management system. It's important that data can easily be exchanged and shared between your system and other industrial automation and control systems. There's another way to expand this interoperability that is overlooked sometimes as well. So if you think about different facility energy management applications that are out there today, in many cases, it's often better to embed the power management web interfaces inside other software environments, which avoids having to re-engineer everything from the non-power management software platform. So it's a much simpler approach, and it provides the user, the customer, a single seamless pane of glass who's using the software. So a single view, you need to think about the interoperability of your system, how it can talk to other systems, how it can embed the data within itself. Power management systems have evolved significantly in recent years. And when I say evolved, I'm talking about they've become much more end user goal oriented versus the past of being more product feature oriented. Because of that, you need to provide, you need to search out a power management system vendor who is able to build specific applications to make your life easier. You know, some of these applications that are available, they're designed based on architectures and configurations for things like network control, electrical control, power source management, different distributed energy resources, capacity management that we talked about earlier, having reports and visualization tools to be able to manage the different loads throughout your system, power quality, performance, and compliance, breaker performance, electrical thermal monitoring, so having the visibility of thermal conditions within your system, being able to identify hot spots on conductors for more proactive maintenance versus your periodic 2 to 3 year maintenance cycle, at which point there could be failures or faults that have been occurring for quite some time. So having quick visibility to those problems before they propagate. Utility bill verification. So being able to check for mistakes on the utility bill, being able to shadow bill for that bill verification. And finally, energy usage and performance. So lowering energy consumption, managing different energy KPIs. You want to look for power management tools designed for your specific application and purpose. When it comes to selecting a power management system provider, you want to choose one that's looking into the future, one that's designed to work with more complex and modern electrical distribution systems that integrate all kinds of different components that you see here listed. So the example shown here is a self-sufficient microgrid. It produces its own power from a variety of sources that you can see. Different generators, hydrogen fuel cells, wind turbines, solar arrays. Such a sophisticated network can be highly efficient, but you've got to have a power management system in place to manage something like this. So we're coming to the end of the presentation. I wanted to make a final recommendation on how to maximize the power performance system. And that being to remember that it's not just about the technology. The technology, of course, is important. That's what we've talked most about today. But you also need to be backed by experts who can support you every step of the way. Your electrical distribution system is a critical asset. It really powers your business. So don't let it just anyone design, deploy, and service the system. Only work with vendors and service providers who specialize in the field, specialize in electrical equipment and power quality monitoring. They're going to be much more equipped to help you operate in a safe, reliable, and efficient manner because they truly understand power management and all aspects of it. So wrapping up, a couple final remarks to kind of summarize what we've talked about over the last hour. We've talked about electrical distribution becoming more complex, while at the same time, electrical distribution equipment getting more intelligent. That leading to companies who own and operate large and critical facilities They're looking for ways to harness technology to reduce expenditures without making a compromise on the safety, the reliability, and the efficiency of the delivery of their power to their facility. This is driving the need for more sophisticated power management systems that are designed to serve the facility management personnel that rely on them every day. I highlighted key things to look for in modern power management software platforms and explained how the systems are specifically designed for electrical monitoring and power quality analysis. I pointed out that power management software platforms will possess special features, special capabilities that are not found in any other SCADA system or building management system software platforms. And finally, I closed with the fact that it takes more than the technology to get the most out of your system. It takes people who are experts in electrical equipment and power management. And it's this combination of technology and expert advisors that will bring you results and ultimately help you maximize your power system performance. All right, so Amy, I think we're at the Q&A point.
Yes, we are. Thank you very much, Drew, for that excellent presentation. Just a reminder, you can go to the bottom of your screen, just hover over the bottom, the Q&A option should appear, and you can click on that and submit your questions for Drew. But we do have a few, so we'll get right to them. Drew, we've got a question regarding the monitoring software. What electrical equipment or devices are required to collect the data to use in the software?
There's a whole host of different devices. So there was a slide that we covered that showed all kinds of different smart connected devices. So everything from the most advanced power quality meters down to more basic meters as well. Those are primarily, when you're looking for electrical data parameters, those are some of the most common devices that feed up into the software. But you've also got smart devices like the smart intelligent circuit breakers. You've got intelligent communicating protective relays. You've got communicating power quality equipment. So all of those different devices and equipment are natively supported in the power management system software. Also kind of backed by that built-in data model that I touched on as well, for everything to communicate and talk seamlessly between each other.
Great. Regarding harmonics, does LED lighting cause more or less in comparison to ballast lighting?
More or less, I don't know the answer to that. There is some extent of harmonics generated by LED, but off the top of my head, I don't know if it's more severe or less definitively.
Sure. Drew, can you just talk a minute, based on implementing a power management system, do you have to work with your utility to implement that, or is that something that in the facility you can do on your own?
You're absolutely able to do it in the facility on your own, on the demand side. Okay. When you get, I guess, outside the facility on the utility side, that's when you'll need to speak with your utility. But everything from the incoming transformer, the load side, you're able to add power meters, energy meters to your equipment on your own.
Great. And would you say, is there an average size building or energy use in a building that would really benefit from a power management system?
I guess it depends on your goal. If you are wanting, or you are concerned about the power quality coming into your facility from the utility, you would probably be a larger industrial critical power, even a commercial building type customer, all kinds of different sizes of those facilities. If your goal is to understand the energy consumption of a specific circuit or specific load, obviously that can be applied to any non-critical facility of any size. So a small retail building, a gas station type thing if you're just looking for energy usage. So it just depends on what your objectives are in implementing a power management system and the extent of the information that you're wanting to get out of it.
Great. We've had a question in reference to networking backbone. Do you recommend this be used with a BMS network or say one building automation network backbone for all systems?
So I guess this comes back to the interoperability. There are different plugins and different methods to tie your power management system into building management system. Obviously, if you're kind of looking for that single view, that single pane of glass, that's definitely one route to go, is having that integrated into the BMS. I guess it kind of depends on the specific situation and what the customer or user would be wanting to get out of it. Is having those two disparate systems more confusing, or are there different people monitoring different elements of the building and the power management? So either way, there's a way to integrate those two together, and there's obviously the option to keep them separate, depending on dynamics of the facility and the personnel involved.
Great. And we've had a few questions regarding Internet of Things or using Wi-Fi or wireless transmission for those devices for real-time monitoring. Do you have any input on using Wi-Fi for those devices?
Yeah, so we're definitely seeing more wireless devices come onto the market. We've seen things like wireless thermal sensing, so being able to monitor the temperature of a bus bar or a conductor connected to close to a hot circuit breaker, for example, and feeding that back into the power management system. We've seen basic current sensing devices that are wireless that are able to be, excuse me, and able to be installed, upstream, downstream of a circuit breaker, to monitor the current level, to monitor the energy, and feed that information back to the system wirelessly. So we're definitely seeing more and more of that, depending on the facility and the market segment that these wireless devices are sold into. There's going to be, more acceptance of some types of facilities and customers than others for cybersecurity concerns and things of that nature. But it's definitely moving in that direction, more and more wireless sensors of one kind or another. Great.
And with that, we are at the top of the hour, so I would like to thank Drew and Schneider Electric for providing this webcast. I think it was very beneficial. And just a reminder, you will receive a copy of the slides, and the archive will be available at facilitiesnet.com/webcast. So thank you again, Drew, and thank you everyone for joining us today.
All right, thank you very much.